This circuit is a sawtooth wave generator. It creates a wave that goes up and something shorts it back to 0.7 volts. It goes up, gets shorted back to 0.7 volts. There seems to be a trigger happen right here, and it charges again. So if we look at this part of it, we can look at a cap and a resistor. There just happens to be a resistor in parallel with it that forms a charging circuit for the cap. So we have an RC time constant for that. That RC time constant looks like a circuit like this. We have our 1K ohm right here. We have a cap that's charging. We also have a 1K ohm, which is a combination of the 900 and the 100. So that's this one. Okay. How do we deal with that? We have charging current going this way, and some of it goes this way. The cap still charges at a rate like this. It's obvious that we're going to have to Thevenize this circuit. Thevenin circuit looks like a source and a resistance that would be charging this cap. Okay, we have ETH. If you look at it, you remove the load, which is the cap, and look at the voltage produced right there, right here. This is 110 volts, so this would get to 55 volts. Just your voltage divider formula. And in order to do the RTH part of it, you remove the load and you look at the circuit with the source, a voltage source, shorted to ground. If it was a current source, you'd open it, and voltage source, you short it. So if this is hooked to ground, that would give us a circuit that looked like we had two 1K ohm resistors in parallel. So RTH is 500 ohms. The RC time constant is 0.2 microfarad times 500 ohm equals 100 microseconds. 20% of that, which is actually what they designed the circuit for. They designed it for 20%. Let's see, this is 63.2% of the total, where it's headed for 110 volts. Actually, it's only 55. We would have 20% of that only uses this bottom portion that is relatively a straight line, and so 20% of that is equal to 20 microseconds, and 1 over 20 microseconds is equal to 50 kilohertz. So this thing will actually run at 50 kilohertz. Now the question is this voltage gate trigger is at 1 volt, and so I need 1 volt here. So if this charges, this one's actually kind of obvious. If this one charges to 10 volts here, then I will get 1 volt here. When I have 1 volt here, I also need the 200 microamps. Current path is this way, and charging current through the cap. When I have a current here, this the voltage of the cap builds up so that when I get 10 volts here, I'll have a volt across here. I'll also have my trigger current coming from this cap, which is something I may or may not have to deal with. When I have less than 10 volts here, let's say 5 volts, I would have about 0.5 volts here. Will there be any current going into this gate? The answer to that question is yes, there will. It will be, we have to deal with a current into this gate. 100 microamps will not make this SCR fire, and 0.5 volts will not make this SCR fire. I need to get this to at least 1 volt and 200 microamps. So I'll have the 200 microamps, all that current going through this resistor, but not this one. 200 microvolts, or 200 microamps times 900 ohm is equal to about 0.18 volts. So I would say that this has to get to at least 10.18 volts in order for it to fire. The quick and dirty method says it gets to 10 volts. We don't care about 200 microamps. If this was 20 milliamps, you would care. Of course, you would have different values here if that was 20 milliamps too. So 200 microamps times 900 ohms is 0.18 volts. So this reaches about 10.18 volts. Quick and dirty method says it reaches 10 volts. How much current actually goes into this when we have 1 volt? Let's see. To do this, we have to use our friend Thevenin. You look at the circuit from the standpoint of the gate here, because this is the load. What you see is the cap as the source, and so you short it to ground, and you see a 900 ohm in parallel with a 100. That's equal to 90 ohms, and this has to get to 1 volt. Plus whatever this voltage is here at 200 microamps. So 90 ohms times 200 microamps is actually small enough that we don't really care. So if this gets to 1 volt, then we'll have the 200 microamps here, which tells me that I don't need this 0.18 volt here, and I can just charge the cap to 10 volts, and this SCR will fire. So, to recap, this cap charges through these two sets of resistors, charges up to 10 volts here. The SCR fires because it has 200 microamps and 1 volt on the gate, and it shorts it all out, so all that current from the cap goes this way. We are dealing in conventional current here. At this point here, the SCR gets below its holding current because the cap is discharged, and so the cap starts charging again up to the 10 volts, and then it discharges until the holding current is gone, and then charges back up.